Solving quadratic equations. In this example, we asked to solve for x and we're given the quadratic equation x squared minus 4x plus 5 equals to 0. In order to find the solutions or to solve for x, another term would be to find the roots of this equation. We're going to use the quadratic formula. So for us to substitute the values into the quadratic formula, we need to identify the value of a, and a is the coefficient of x squared, and I see that a has a value of 1. B is the coefficient of x, and b has a value of -4. C is the constant, and that value is 5. So we substitute these values into our quadratic equation. We have x equals to minus b, so it's minus -4. So that will give me 4 plus or minus b squared is -4 squared minus 4 times a times c. And this is divided by 2 times a, which is 2 times 1. And that equals to 2. We simplify, so we get x equals to 4 plus or minus. So we have the square root of 16. -4 squared is 16. Subtract 20 gives me -4 all over 2. Now looking at the square root of -4, if I have to enter this into the calculator, you would get an error reading. That's because the calculator cannot calculate the value of the square root of a negative value. Now looking at the square root of -4, we can write the square root of -4 as 4 times -1. And when we are asked to find the factor or the square root of two factors, we can find the square root of each factor separately. So we can write this as the square root of 4 multiplied by the square root of -1, and this gives me 2, and we know by definition that the square root of -1 is I. So we have that x equals to 4 plus or minus 2i over 2. I can simplify further by taking 2 as the highest common factor out in the numerator and then dividing it with the 2 in the denominator. So I have that x equals to, let's factorize, so we have 2 into 2 plus or minus I all over 2. And dividing, we see that we have our two roots. Since we have a quadratic equation that we factorized, we have x equals to 2 plus I or we have that x equals to 2 minus I. So these are the solutions to my quadratic equation. Now, looking at these solutions, we see that both solutions are complex numbers, and in fact they are complex conjugates of one another. Let's just recap. The complex conjugate of 2 plus I will be 2 minus I, and the complex conjugate of 2 minus I will be 2 plus I. So whenever we factorize a quadratic equation, and if the roots are complex roots, or the roots are complex numbers, these numbers will always be complex conjugates of one another. Using the knowledge of complex conjugates, we're going to use it to help us to answer the following question. We are asked to find a quadratic equation, so we're looking for an equation in the form of ax squared plus bx plus c equals to 0. And we are given that 2 minus I is one of the solutions of this quadratic equation. So we know that x equals to 2 minus I. And having a look, we see that this is a complex number, so we know that the second root, which I'm going to call x2, will be the complex conjugate of 2 minus I, which is 2 plus I. So I have the solutions to the quadratic equation. I use these solutions now to find the equation. So if x equals to 2 minus I, then x minus 2 minus I will equal to 0. all I've done is taken the number 2 minus I across the equals to sign. And we say that this is a factor. X minus 2 minus I is a factor. Similarly, x minus 2 plus I equals to 0 will be my second factor. And I can now multiply these two factors. So I have that x minus 2 minus I multiplied by x minus 2 plus I will equal to 0. So if each factor equals to 0, then the product of the two factors will also equal to 0. And when I multiply this out, I will get to the quadratic equation that I'm looking for. Now I'm going to first do it in a very long method, and then I'm going to show you a much easier method. So let's do it the longer way. And what we're going to do now is we're going to apply the distributive law, and we're going to multiply our terms. So we got x multiplied by x will give you x squared. Then I'm going to multiply x by 2 plus I, so that gives me minus 2 plus I times x. I'll multiply negative 2 minus I times x. I have minus 2 minus I times x. And I multiply my last term, so it's going to give me plus 2 minus I times 2 plus I, and this must equal to 0. Now we're going to remove the bracket, so we need to simplify. So we have x squared minus 2x minus ix minus 2x plus ix. We need to multiply these two complex numbers, and we see that they are a difference of squares. So you can FOIL out, and you would get 2 times 2 will give you 4 if you multiply the first term. But you would notice that the next two terms cancel each other out, because I have plus 2i minus 2i, which gives me 0. And then when I multiply my last term, I have minus I squared will equal to 0. We're now going to add like terms. So we have x squared. We see that minus 2x added to minus 2x gives you minus 4x. We have minus ix plus ix, which is 0. Here I have 4 minus I squared. We know that I squared is negative 1, so this is going to be plus 4 minus negative 1 equals to 0. So my quadratic equation will be x squared minus 4x plus 5 equals to 0. Right, so it's very easy to make mistakes when we use the above method. We're now going to have a little quicker, shorter method. So we start the same way. I've just copied down the question again, which asks us to find the quadratic equation, and we know that x equals to 2 minus I is one solution. So we start the same way. We know that x1, or the first solution, is 2 minus I, and so my second solution will be 2 plus I. Because my solution is a quadratic, sorry, not a quadratic, a complex number, the second solution will be its complex conjugate. We once again write down the factors. So I have x minus 2 minus I will equal to 0, or x minus 2 plus I equals to 0. I once again multiply the two factors. So I have x minus 2 minus I multiplied by x minus 2 plus I will equal to 0. Right. Now, we know that when we multiply our first term, so we multiply the first term in the first bracket with the first term in the second bracket, we're going to get x squared. Then what we do is we find the sum of the two roots, and that is the coefficient of x. So it's minus the sum of your two roots, and this is the coefficient of x. plus, and to find your constant, you're going to find the product of your two roots. And that will equal to 0. Right, so let's continue. So we have x squared minus. Now the sum of my two roots are 2 minus I, which is added to 2 plus I. And that's the coefficient of x. The product of my roots is going to be 2 minus I multiplied by 2 plus I. So we have x squared. Adding like terms here, so we have 2 plus 2 gives me 4, and my imaginary numbers cancel, so I have minus 4x. I multiply my constant, so I'm just going to open up a bracket here. And once again, this is the difference of squares, so 2 times 2 will give me 4. Then I'll have plus 2i minus 2i, which is 0i. And then I have minus I squared, and I know I squared is minus 1, so it's going to give me minus 1. So immediately we come to our quadratic equation, which is x squared minus 4x plus 5 equals to 0. So this is the preferred method of finding an equation if you're given a complex root, and it is advisable that you just learn that little rule there.